Good morning, Precalc. As you can tell, I was on my way to get ready to go to school, and then I got the text literally as I was right about to walk out the door, hence my beautiful outfit. As you can tell, I'm so thrilled about having another AMI day, especially on one of the most important days that we're supposed to learn. Oh my gosh, I'm quaking in my boots right now. I'm just so excited. Anyway, today I want you guys to, before watching this vid, I want you guys to read through 5.4 notes. Now, for those who don't know, every single time we've had a unit this year, I post the notes ahead of time for the entire unit. So the notes are actually under, if you go in the Google Classroom, click on classwork. That's one of your best friends right here. Most important tabs from my Google Classroom. It's completely organized there too. Don't just be like, oh, it's not on the stream. Look under classwork. It is the most straightforward thing. Since we are on trig test 1, it'll be under trig test 1. And then there's this place called guided notes. Okay. Click on guided notes, filled out way ahead of time. I go through a very meticulous, gory detail in those notes too, by the way. They're color coded and everything. They're beautiful. Spent a lot of time over my summer break, my own time, right? I didn't get paid for that, no. It was just so fun for me. Oh my gosh. And since we are on 5.4, click on 5.4. Now, if I'd known we weren't going to be in school today, I would have given you the notes for it. That way you could fill it out on your own, kind of. But you just kind of have to look through it. It is a very, very heavy review. So imagine if we didn't do that geometry review, how screwed we'd be, right? But we did it, so good for us. Now, there's a few things that I haven't taught you from those notes yet. Hence why I'm making a video of it, because it's decently important. Two main things I want you to look at. You have 3 other functions for trig that we're working with. One, we're not using regular American letters. We're using Greek letter theta, the circle slash, to represent an angle now. We've graduated, right? We're in the big leagues. Now, you got your SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine of this theta angle is adjacent over hypotenuse. Tangent is actually going to be sine over cosine. That's how we're going to define it. It's going to save us so much time and headache later. However, to go through it, it kind of simplifies down to the opposite over adjacent for triangles. So, and the reason why is because, you know, opposite over hypotenuse, which is sine, over cosine, which is adjacent over hypotenuse. And then you could flip it, so opposite over hypotenuse. And then keep it first the same, change it to the multiplication, and then flip your fraction. The hypotenuse always cancel. So simplifies down to just opposite over adjacent. But that's beside the point. That's always going to work out like that. 99% of the time. Yes. But then you got 3 other ones. You got cosecant, which is the reciprocal function for sine. And that's going to be 1 over sine, which is hypotenuse over opposite. So remember, reciprocals just flip your fraction. Now, why is cosecant with sine instead of cosine? That's so confusing. Well, the reason why is calculus, and I don't want to get into it, so just take my word for it. Usually they're going to be right next to each other, so it's going to be rather obvious, but get in the habit of kind of flipping it in your head, right? And how do you find cosecant on a calculator? Well, just do sine and then do 1 over that. So secant, 1 over cosine, so hypotenuse over adjacent. Cotangent is straightforward, it's 1 over tangent, so which is adjacent over opposite. One really important thing, though, that's at the very end of the notes, so if you scroll all the way down, are the 3 really important angles that we're going to be looking at for the rest of the semester. You need to have these memorized, not by tomorrow, but like soon, because you're going to really be benefiting from this. So it's these 3 main angles. And we got a few more too to worry about, but for the time being, the 3 main ones. 30, 60, or 30, 45, and 60. So having those locked in and key is important, and understanding where they come from is also important. Now, I drew out the triangles on the notes, so make sure you look at those and try to see why these are the way they are. But sine of 30 being a half, cosine of 30 being root 3 over 2, tangent of 30 being root 3 over 3. You don't really need to worry about cosecant, secant, and cotangent of those angles, because all you do is just flip it over, and it's easier to memorize these three and then just remember how to flip it rather than doing the other one. And 9 times out of 10, I'm only going to ask you about these three anyway. So, and how do I have this memorized? It's so much work. Well, I'll teach you some methods and quick ways to do it once we get to 5.6. But for the time being, just take my word for it. Sine of 45, root 2 over 2. Cosine of 45, also root 2 over 2. Tangent of 45, 1. Why is that? If you remember, tangent, sine over cosine, and root 2 over 2 divided by root 2 over 2, it's the same thing over itself. So it's like saying 5 over 5. That's 1. Interesting. Keep that in mind. That'll be very important later on. Sine is 60 is root 3 over 2. Cosine of 60 is a half. Whoa. It's like it's flipped from this. What a coinkydink. There's a reason for it. Tangent being just root 3. Well, that's pretty similar to this, isn't it? It is. Keep it in mind. But I actually want to walk you through two examples, number 4 and number 7. So, number 4, example number 4. So, find the 6 functions given the triangle. And that's 6, 6 root 3, and then theta right there. And that's the right angle. So, I'll teach you how to do it. It should be very, very heavy review from the geometry review you did earlier this year. So let's take a look. Well, firstly, we have the theta right there. It looks like we have the opposite side of that angle. Looks like we have the adjacent, but we're missing the hypotenuse. We don't have the hypotenuse. Hypotenuse is always on the opposite side of the right angle. So yeah, let's find the hypotenuse first. So using good old Pythagoras theorem. So you got it. A squared, let's do 6 root 3 squared, plus b squared is equal to c squared. So yeah, let's solve for c. So 6 root 3 squared, that's just 6 squared, which is 36, times root 3 squared is just 3, plus, and then 6 squared is 36, is equal to c squared. And then, well, 36 plus 36 times 3 is also 36 times 4. So then, 36 times 4, because I don't want to do 36 times 3 off the top of my head. It's too much. C squared, 36 times 4 is just 144. So C is 12. Plus or minus 12, but hypotenuse is always positive. So, yeah. So this missing side here is 12. Perfect. So now, I could have told you that right from the get-go because it's a very special triangle that you're about to see. And if you recognize it, you recognize it. The sine of theta, so opposite. So the opposite side is 6 root 3. And now hypotenuse is 12. So you got 6 over 12, which also just happens to be a half. Interesting. Now, and also a good way to do it is just to go and do cosecant right after, because that's just 1 over sine. So that's just going to be, flip it over. You got 2 over 1 or just 2. Cosine, so your opposite side, or the adjacent side over the high. Oh, my word. I'm tripping. 6 root 3 over 12. So that's just going to be a root 3 over 2. So this is actually root 3 over 2. My bad. I got it mixed up. Root 3 over 2. So this is going to be 2 over root 3. Or 2 root 3 over root 3. Same thing with cosine, it's a half. I got that mixed up because it's adjacent over hypotenuse. And then secant would be 2. Tangent would be opposite over adjacent. So 6 root 3 divided by 6. So that just turns into root 3. And then cotangent would be √3/3. Yeah, it's been a long day. Okay. Anyway, your question one on Google form is going to be, I don't even know. What's your favorite Pop-Tart flavor? I know I've already asked that in that one survey, but I'm eating a Pop-Tart right now and like, I'm just kind of burnt out on AMI days. Anyway, let's go through example number 7. I thought I had something better than that, but no, I guess not. I'm done. So cosine, so example number 7. It wants us to find all 6 of the trig functions given that you know your cosine is 5/9. Now, how do you draw this? Or how do you start this? Well, spoiler, you draw it. So how do you draw it? Well, just draw a right triangle. We've only been working with right triangles so far, so that's the idea behind it. So draw a right triangle. Right angle right here. And pick one of the other angles. Label this one. Label it theta. And here, we know that theta, the cosine of this, so the adjacent side to the hypotenuse, is going to be 5/9. All right. Now that we got that out of the way, now we need to find the missing side length here. Pythagorean theorem. So we're missing a side. So let's call it x. You got a squared. So let's make xa plus b squared 5 equal to c squared, your hypotenuse. So then you got x squared equal 1, and then x squared is equal to 56. I think so. Yeah, sounds about right. And then so x is going to be equal to, well, 4 goes into 56 into that, so 2√14. Perfect. So 2√14. All right, perfect. Now we just need to find the 6 trig functions based on that. So we already got cosine. That was literally given to us, so 5/9, meaning we can get secant for free. So 9/5. So now we got to find sine, cosecant, tangent, cotangent. So sine would be your opposite side, so 2√14 divided by 9. So that means cosecant is going to be 9/2√14, which is going to give us 9√14 divided by 28. You simplify it without a radical on the bottom, which is how we usually do it. So then opposite over adjacent, so 2√14, 5, and then 5, or cotangent, I gotta write that out. Cotangent is 5/2√14. So that's going to be 5√14/28. Okay. So your objective is to read through 5.4. I know you don't have the notes for it, so just read through them and we'll fill out some examples together tomorrow. And I wish I would have given you homework on it, but before. But whatever. I also recommend looking through 5.5 and 5.6. You only got 3 sections left. So 5.5 should also be really, really nice review. So that way you can get ahead and try to catch up. 5.6 is the most important section in all of trig. Period. I'm not even not even kidding. 5.6 is so important. We're spending 3 full days minimum on that section alone. So we'll go through 5.6 at some point, depending on how we get this, maybe Wednesday, Thursday, Friday, maybe Thursday, Friday, Monday, but our test should be coming up next week. So start getting ready for that. Make sure you understand radians You don't need to have a very deep understanding of the revolutions and stuff, just know how to do the basics. Don't stress about that, but the bread and butter test one is going to be this type of stuff. So, so long as you have a good idea of how to do 5.4 and 5.5, you should be set. And if you want to get ahead on your homework, like I have the keys there too, and I'm not going to assign every single one of them, but you should be able to know how to do them. I got the answers there, so if you really want to try out a few examples on your own, yeah, Google question number 2. Should be math related, so shoot, I had a really good one too. Um, oh well. I guess Google question number 2 is going to be, do you have any questions from example? Do you want to go through any questions in class from 5.4 notes? Yeah, that'll be it. All right, cool. Have a good one.